Today we're going to take a look at relationships of angles and depending on where their vertex is in regards to the circle. The first one we're going to take a look at here is if the vertex of our angle is on the circle. So go ahead and underline that. When the vertex of our angle appears on the circle, just like in our example here, C, it is always going to be equal to 1/2 the intercepted arc. So I'm going to take a look at our picture here. We have angle BCD, and its intercepted arc is the arc that this angle cuts off of the circle. It's equal to 112. Well, I know that I can find the measure of angle DCB simply by taking 112 and dividing it by 2. Therefore, 1/2 of 112 degrees is going to be equal to 56. So the measure of this angle here, whose vertex is on the circle, is half the intercepted arc, so it's 56 degrees. Our next example is when the vertex of the angle is inside the circle, not necessarily at the center. If it were at the center, it'd be a central angle, and that's always equal to the intercepted arc. However, let's think of the case when it's inside the circle, but not on the center. This will be equal to 1/2 of the sum of the two intercepted arcs. Okay, so if you take a look at our picture, here are an example. I have angle 1 right here, and its vertex is E. It is inside the circle, and notice that it's not on the center of the circle, A. Therefore, the measure of angle 1 should be equal to 1/2 of the sum of its two intercepted arcs. Those intercepted arcs are DB and CF. Therefore, this should be equal to 1/2 102 plus 90. When I add that up, I get 1/2 of 192, and that's going to result in 96 degrees. Therefore, angle 1 and this angle over here, because they're vertical angles, should both be equal to 96 degrees, which would also mean that you're going to be able to find these angles too, because altogether these angles should add up to equal 180 degrees. So 96 take away from 180 should give you the measure of these yellow angles as well. Our third situation occurs when the vertex of that angle falls outside the circle. And this is we're going to be able to find the measure of this angle by taking 1/2 of the difference. Difference means subtraction. 1/2 of the difference between the two intercepted arcs. So if I take a look over here, here is angle C. It is clearly outside of the circle. So its vertex is outside, therefore I got to take a look at the two intercepted arcs of that angle. They are arc BH, which is 88 degrees, and arc FG, which is 24. Therefore, I should be able to find the measure of angle C by taking the difference, 88 minus 24, and then dividing that by 2. When I find that, I'm going to find that that measure of that angle C is 32 degrees. Now, there is a little bit of a trick to this. You need to know which arc to subtract from the other. So one way of simplifying this is to say that the measure of this angle, whose vertex is outside, is always going to be 1/2 of the big intercepted arc minus the small intercepted arc. Let's take a look at a few examples. It says find the measure of FGH. So FGH is this angle right here. You have to start by asking yourself, where's my vertex? The vertex here is on the circle. And when it's on, I know that it's always 1/2 of the intercepted arc. Well, my intercepted arc here is 216 degrees. So 1/2 of 216, and that's going to give me 108. Our next example says find the measure of arc LM. Now I'm finding an arc measure when I'm given this angle. So if I take a look here, I see that the vertex again is on the circle. And because it's on the circle, I know the relationship between the arc and the angle measure is 1/2 of the arc is equal to the angle. But I have the angle. So 64 degrees needs to be multiplied by 2 to get the arc length. So 64 times 2 is going to give me 128, and therefore that's equal to the measure of arc LN. Example 3 asks me to find the measure of ABD. This angle right in here, and I see that the vertex now is inside my circle. Because it's inside, I know that it's got to be half the sum of the two intercepted arcs. So angle ABD and angle EBC, remember, are congruent because they're vertical angles. I'm going to use those to find my intercepted arcs. That's arc EC and arc AD. So I take 65 and add to it 37. That should give me 1/2 of 102, and that's going to result in 51 degrees. In our last two examples, we're going to find the angle measures or arc measures again. So this one asked me to find the measure of arc KM. I recognize that my vertex is outside my circle, and therefore that vertex, which I know is 25 degrees, must be equal to 1/2 the big arc, in this case, which is 83, minus the small arc, which is x, and that's what I'm trying to find. So I need to work backwards to get x by itself. I'm going to start by moving the 1/2 over by multiplying both sides by the reciprocal of 1/2, which is 2. So multiply both sides by 2, that will cross it off here. If I multiply 25 by 2, I get 50. That's now equal to 83 minus x. I'm going to subtract 83 from both sides, and that's going to give me a negative 33 is equal to a negative x. Now be careful, remember that negative stays with the x. And so if negative 33 equals negative x, that would mean a positive x is equal to positive 33 degrees. And therefore, Km, the arc Km, is equal to 33 degrees. In example 5, I want to find the measure of ACD. Again, this is an angle whose vertex is outside my circle. I know that that angle is equal to 1/2 the big arc, which in this case is 200, minus the small arc, which is 74. So 200 minus 74 is going to give me 126, and half of 126 is going to give me 60.